Okay, this is number 13 of the problems in your modules. We are going to look for the value of R, and we're going to use KCL and KVL principles to solve for the value of R. Now, so we don't have any choice. To get the value of R, we use Ohm's law. So R equals, by Ohm's law, that is voltage of R divided by the current of R. So let us now assume the direction of the current through R. So let us assume it to be in this direction, which is to the right. So this is now our IR. And this, if the direction is to the right, then this should be plus and this should be minus. So this is VR. So the polarity of the resistor depends on the current of R. The resistor always dissipates power, therefore if the current is going to the right, then it should enter the positive terminal. It's always going to be like that. Now, let us do the same for the rest of the elements. So we don't have the current here, so let us assume the current. So this is I1. So if I1 is, the direction is like that, then this is our V1. Now the direction here, let us assume to be going to the left, therefore this should be plus and this should be minus. And if the direction of the current here is going down, let us call this I2 and this is I3. So this should be plus and this should be minus. Now the voltage VO equals 60 volts, and it is positive here and negative here. So our current should be going down because the 12 ohm resistor should dissipate power. Let us call this I4. And I4 is also the current flowing through 18. Now, of course, in the source, it should deliver power, therefore it should enter the positive terminal. So let us call this IS. Okay, so let us not call this V1. Let us just call that the voltage across 45. Okay, so if this is plus minus, therefore this should also be plus minus because the current direction is going towards the left. Okay, let us now start. So where can we get a current or a voltage? Now if we are going to have a KCL here, we cannot get anything because the currents going towards the node, this node, and going away from the node is given. And also with this, if you try KVL, then we are going to determine the loops. So this is one loop. We cannot get anything there because VR, the voltage across this, two voltages are not given. Here also, we cannot get anything if you use this loop. So let us just use the outer loop. In the outer loop, we have voltage here. We don't have voltage here, but we have definitely voltage here. Why? Because I4 can already be solved. So let us get I4. So I4 equals voltage divided by resistance. What is its voltage? VO, but what VO is already given as 60. So 60 divided by 12, therefore I4 is 5 amperes. So we already have the value of I4. Therefore we can compute for the voltages of both these resistances. Okay, so let us try the outer loop. So our loop 1 is this. Let us call that loop 1. So, KVL at loop 1. KVL at loop 1. So KVL at loop 1, let us start with the voltage source. So negative 240. And then going here. So plus the voltage across 45 is 45 times its current, which is I1. And then going this direction. So plus what is 12 and 18, since only one current flows through them. So let us just combine 12 and 18 as 30. And what is their current? The current we have already calculated as 5. So, and then wala na. So equal 0. So we can now get here I1. I1 therefore equals, so 240 minus 150 is 90. 90 divided by 45 is 2 amperes. So we already got the value of I1. Now if I1 is given, we can now get the value of I2. Why? Because at this node, let us call this node 2, node 1, the current in this branch and in this branch are already given, so we can get I2. So KCL at node 1. KCL at node 1. So entering equals leaving currents. So negative I1. And by the way, I1 we have already gotten as 2. Let us put there 2. And then plus I2 going away, that is why plus. And then plus I4. And I4 is already given also as 5 equals 0. So there are only 3 currents flowing, going towards and going away from that node. So we can now get the value of I2. I2 is, this is negative 5 plus 2 is negative 3 amperes. So our goal is to get VR and IR for us to be able to get R using Ohm's law. So let us continue. If the current is current I2 is already given, then the voltage of 10 is already given, and we can now get the value of I3 by applying KVL on this loop. Let us call this loop 2. KVL at loop 2. So KVL, let's start with 180. So negative 180 times its current is I3. So that's the voltage across 180. Minus 10. The voltage across 10 is 10 times its current, which is I2. But I2 is already given. I2 is negative 3. Let us put negative 3. And then next plus 12 and 18 is 30. Combine them. Times the current flowing through them is I4. So I4 is 5. The answer is 0. Equate that to 0. So the unknown here is only I3. We can compute already for I3. So this is 150 negative, and then negative positive, so negative also 180. So negative 180 divided by negative 180 is 1. So I3 now is 1 ampere. Okay, so we already calculated the value of I3. We can now get IR if we're going to perform KCL here at this node. Let us call this node 2. So KCL at node 2. KCL at node 2. So look, I3 is going towards the node. o I2. So that is negative I2. And I2 is negative 3. So let us put there negative 3. And then uh, I3 is away from the nodes plus I3. But what is I3? I3 is 1. Here, this one. And then IR, how about IR? It's entering the node. So minus IR equals 0. So here we can already get the value of IR. IR is 1 plus 3 equals 4. So IR is 4 amperes. We just need to get the value of VR to get. So we only need to get the value of VR to get R. So IR is already solved. Let us get the value of VR. How do we get that? Can we perform KVL here to get the VR? Yes. So this is now the last step. So let us consider this at loop 3. Then we're going to perform KVL there. So KVL at loop 3. So let us start with the source, negative 240. Negative 240. And then plus VR. And then 180. So plus 180 times its current. But what is its current? I3. And I3 is 1. So 1. So this equates to 0. So VR now is equivalent to 240 minus 180 is 60. Right? 60 volts. So we have already gotten the value of VR and IR. So we can now get the value of R. R therefore equals 60 VR divided by IR, which is 4, and the answer is 15 ohms. And that's how you do it.